Hello students, I Pallavi Sonal, your maths instructor is back. Let's continue from where we left in the last video. So that was in the last video, we learned about the basics of circle. And we started a little bit about chords. So let's move on and learn more about chords. So I'll start with drawing a circle. Okay, this is the center of the circle, and we'll take 2 points on the circle. One is here, and I'll take another point here. Okay, and I'll call this point A. I'll call this point as B. I'll call the center as C. Okay, now with these 2 points A and B, I draw a chord. Okay, and I'll join the 2 points B and A to the center of the circle. Center of the circle was C. So I joined A and B to the center of the circle, which is C. Now I'll make a chord, another chord of equal length, of the same length as AB. And let us call it DE. So I'll call this DE. And I'll do the same as what I did for AB. I'll join the 2 ends of the chord to the center of the circle. Okay. So what we have been given here, we have chord AB equal to chord DE. And then we know C is the center of the circle. Right? We have been given these 2 things. So we'll call it, these are the 2 things which have been given to us. Now, what we are asked is, we need to prove. What do we need to prove? We need to prove that our angle ACB is equal to angle CDE. Okay, so I'll make it. This is the angle, and this is the second angle. So if we draw here, what we are asked to prove is this angle is equal to this angle. Okay, we need to prove that. So how do we prove it? How do we go about proving it? We see what we have been given. AB is equal to DE. C is the center of the circle. Okay. Now, as C is the center of the circle and A, B, D, and E are the points on the circle. So what did we learn about the property of the circle? That's any line joining the center of the circle to a point on the circle is called the radius of the circle. And at any point, we draw any point on the circle and join it to the center. At every point on the circle, it will be of the same length, which is the radius of the circle. So C is the center of the circle. A, B, D, E are the points on the circle. So any line joining the center of the circle to these points form the radius of the circle. And the radius of the circle at whatever point you draw on the circle, radii are equal. So this means CA will be equal to CB, which will be equal to, or maybe, we can write it as AC is equal to BC is equal to DC is equal to EC, because they all form the radius of the circle, right? So this is something which we know from what has been given to us. Now, if we start putting together for these, we see here, right, that ABC is forming a triangle, CDE is forming a triangle. Okay, so we have two triangles here. We have a triangle. We have two triangles here. One triangle is ABC, or maybe I'll say ACB, and the other one is wait, and for some reason this got a bit scrambled. Oh, okay, it's removing the whole thing, so I just need to correct it. So we are considering the two triangles. Here we have the triangle ACB, and the other is the triangle CDCE. Okay, we have these two triangles. Now let us see what we know about these two triangles. We already know that AC is equal to BC, because this is the radii. Okay. Next, what we know? We know BC is equal to EC, again radii, and then we have already been given here, right? We have been told that chord AB is equal to chord DE, right? So we know that AB is equal to DE. This has been given to us, right? So what do we see here? All the three sides of the two triangles are equal. The corresponding sides of the two triangles are equal. So what congruency property does it tell us? It reminds us of, this is the SSS congruency. Okay, it is the SSS congruency. So this means that my triangle ACB is congruent to triangle DCE. So when we write this is my triangle ACB, and this is my triangle, wait, let me do something. Yeah, I'll leave some space here so that I can make this triangle. These two triangles are congruent. Okay. So if these two triangles are congruent, then what will this mean? The corresponding angles will be equal, right? Corresponding angles will be equal. So this will mean the angle ACB will be equal to angle DCE, right? These are the two angles. What is the angle ACB? This is the one. What is the angle DCE? This is the one, right? So we are able to prove that these two angles are equal, right? And maybe we can, write here, hence proved, right? So we proved that angle ACB is equal to angle CDE. So now if we have to put it in the form of a theorem, what will that be? That will be equal chords of a circle subtend equal angles at the center of the circle, right? AB and DE are equal chords. Okay, they were equal chords of the circle with the center C. And we have proved that the angles subtended by these two chords at the center, which means the angle made by these two chords at the center, are equal. Okay, equal chords of a circle subtend equal angles at the center of the circle. I hope this theorem is now clear to you. So now whenever we prove any theorem, right, we also go back and see if the opposite of that theorem, the converse of that theorem is also true or not, right? So what we were given here is, we were given these two chords are equal, right? And then we had to prove that they subtend equal angles at the center. The opposite will be, we are given two chords. We don't know whether they are equal or not, okay? But we are given that the angle that they make at the center, the angle subtended by them at the center are equal. Okay, so what we need to prove in this case is that the two chords are equal. Okay, let's see. Let's copy this once again. Okay, let me copy this circle and let's try. Yes, good. I think the only thing it did not copy is B. So let me try copying it again so that we have the complete thing. Okay, copy and paste here. Okay, so now we have the same circle, same two chords. So now here, as I was saying, what is given here? I have been given as AB and CDR, sorry, AB and DER, two chords of the circle with center C. Okay. And the second thing which I am given is angle ACB is equal to angle DCE. Let me make the angle symbol here. Here. Okay. These two things are given to me. What do I need to prove now? To prove, what I need to prove here is AB is equal to DE. I need to prove that these two chords are equal. So let's get started with this fun proof. Okay. Let's start with whatever we know. We are given AB and DE are two chords of the circle with center C. I'm given the angle ACB is equal to angle DCE. So let's start. First of all, let me copy this and write whatever I have been given here, right? Okay, what I'll do is I'll simply write here because that is going to take lesser time than copying. DCE. Okay. And what else do I know? What else do I know? I know that AC, uh-oh, AC is equal to DC because they are the radii of the same circle. What is the other thing that I know? BC is equal to AC, which is again radii of the same circle. So what can I deduce from these three things? Let me look at these two triangles. I look at triangle ACB and I look at triangle TCE. These are not angle, these are two triangle that I am looking at. Okay. What do I see here? I see here that AC is equal to, this AC is equal to DC, BC is equal to EC, and the angle in between, which is the angle DCE, is equal to angle ACB, right? These two angles are equal. This has been given to us, right? This has been told these two angles are equal. So for these two triangles, ACB and DCE, what can we say? These two triangles, I see here that side, angle, side. The side, one side angle, which is being enclosed by these two sides, and the other side. So AC, BC, and the angle, right? So these are equal corresponding to the two triangles. So this gives us the SAS congruency, and we can say that our triangle ACB and the triangle DCE are congruent. When we say congruent, we make this sign, and these two are triangles. So triangles. Okay. Now these two triangles are congruent. So what does that mean? What can we say? We can say the corresponding corresponding sides AB and DE are equal, because we proved that these two triangles are congruent. So the corresponding sides of the two triangles are equal, right? So AB and DE are equal. I made already this equal to sign. So I don't need not write are equal. It shows it is equal, right? So we have proved. Hence proved. Yeah. And let's write what theorem does it lead to us. So what we were given, if AB and DE are two chords of the circle with, or maybe, let's not write in those terms. Theorem is generic. So I'll write in the generic form, which is two chords of a circle subtending equal angle at the center of the circle are equal, right? Two chords AB and DE, they are subtending equal angle at the center. The angle ACB is equal to the angle DCE. So this leads to the proof that AB is equal to DE. Two chords of a circle subtending equal angle at the center of the circle are equal. This proves the converse theorem, converse of the theorem which we have seen here. Okay, as per your NCERT book, this is the theorem 2. This is the theorem 3. All good so far? So now let us move to the next theorem. Okay. So for that, we make a circle. Okay. And we make these two chords. This is one chord. This is the second chord. Okay. Now, this is my center. Okay. So I'll call this A. I'll call this B. So AB is one chord. Call this C. I'll call this D. So AB is one chord. CD is another chord. Okay. And then what I'll do is I'll draw a line which bisects AB and which bisects CD. Actually, for this proof, we don't need to show two chords. Okay, so what I'll do is I'll just remove this chord. Okay, I'll just keep this. And let me name the center of the circle as O. Now, what I need to prove is a line which is joining the center of the circle to a chord of the circle, center of the circle to the midpoint of the chord of the circle is actually perpendicular to this chord. Okay, so when I write it, what is given to me? What is given to me? Given is CD is a chord of the circle with center O. This is given to me. And then I'll be drawing a line. So let me draw a line. So first, let me mark the midpoint of this circle. Sorry, is of this chord. So assume this is the midpoint of the chord. So let me call this midpoint. What should we call it? Let's call it E. E is the midpoint of this chord. Now what I need to do is I need to draw a line from the center of the circle to the midpoint of this chord. So let me draw a line joining the center of the circle to the midpoint of this chord. So I'll say that, maybe I'll just remove this so that it is a bit clear. And remove this also and make a nice fresh line which is straight. Okay. So CD is a chord of the circle with center O. What else is given to me? OE. E is the midpoint of the chord CD. What does that mean? Okay, we'll see what does that mean. And then I have to OE is the line joining the center of the circle to the midpoint of the chord. Okay. OE is the line joining the center of the circle to the midpoint of the chord. These three things are given to us. Now, what do we need to prove here? To prove, what we need to prove is OE is perpendicular to CD. So what we need to prove is this line joining the center of the circle to the midpoint of the chord is perpendicular to the chord. Okay, OE is the line joining the center of the chord to the midpoint of the chord. CD is the chord. So we have to prove OE is perpendicular to CD. So let's start with the proof. Now we have been given CD is a chord of the circle with center O. E is the midpoint of the chord CD. So when E is the midpoint of the chord CD. So what this means is CE will be equal to DE, right? Now another thing what we can do here is we join these two. What we are joining is the center of the circle to the endpoints of the chord. Okay, so I joined OC, I joined OD, right? So what do we see here? We have two triangles here, OCE and ODE. Now what we know is OC is equal to OD. Why are they equal? Because they are the radii of the circle. So they are equal. OE is the common side, right? This OE side is something which is common to this triangle, OCE as well as ODE. So OE is equal to OE, right? So when we write, these two triangles, OCE, and we are considering the other as ODE. We consider these two triangles, triangle OCE and triangle ODE. We see OC is equal to OD because they are the radius of the circle. We see CE is equal to DE because E is the midpoint of the chord. This is already given to us. And OE is equal to OE, which is the common side of the two triangles. So what we see here is S, 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 side, side, side. This is the SSS congruency, right? So which means this triangle, these two triangles are congruent to each other. So because these two triangles are congruent to each other, so this means that the corresponding angles will be equal. Corresponding angles of the two triangles will be equal, which means angle OEC will be equal to OED, right? See, this is the corresponding angle OEC, OED. So these two angles will be equal. What does that mean? This is equal to this, right? What did I do? what we are saying is this angle will be equal to this angle, right? So this means, and what we see is these two angles are on the same straight line, right? So these are basically the sum of these angles is making a 180 degree, right? These two angles are supplementary angles. The sum of these angles will be 180 degree because this is forming a straight line. So OEC plus OED is equal to 180 degree. Okay? This is the angle OEC and this is the angle OED. This is the 180 degree. So this means we can also say OEC is equal to OED. So this means we can write it as OEC plus OEC, right? Because these two are equal. So that is why we can say this. This angle here, this will be equal to 180 degree. Which means 2 of OEC is equal to 180 degree, which means OEC is equal to 180 by 2, which is equal to 90 degree. So 2 of angle OEC is 180 degree. So angle OEC is equal to 180 by 2, which is 90 degree. So what we come to know here is OEC is equal to OED equal to 90 degree. Which means we can say OE is, how is OE to CD? OE is perpendicular to CD, right? And then because we proved it, we can write here. Hence, proved OE is perpendicular to CD. Okay, so now we will write the theorem. What theorem does it make? This is the theorem number 4. So the theorem number 4 will be the line joining the center of the circle to the midpoint of the chord is perpendicular to the chord. Okay. This will be the theorem 4. Now you can be asked if the converse of this theorem 4 is also true. So for that, what I'll do is, again, I'll copy this entire thing, this diagram, I'll copy here. And I'll just delete this because this is looking ugly. What I'll do instead is, okay, because we have to prove the opposite. What will be the opposite or what will be the converse of this theorem? In this theorem, in the theorem 4, we had been told that E is the midpoint, right? This is the CD is the chord. And the first thing that we were told is that E is the midpoint of CD. And we had to prove that OE is perpendicular to CD. So here, if we have to take the converse, it will mean that OE will be, we are given that OE is perpendicular to CD, and we have to prove that E is the midpoint of the chord. Okay, so here what will be given to us? We are given that OE is perpendicular to CD. Yes, we are given that OE is perpendicular to CD. We know already, that CD is a chord of the circle with center O, right? OE is a line. OE is a line joining the center of the circle to a point on the chord. To a point on the chord. What is the point called? Point E on the chord. And then what we have to prove now, this is to prove that E is the midpoint of the chord. Or in other words, what we need to prove is that CE is equal to DE. If we prove that CD is equal to DE, it will automatically mean that E is the midpoint of the chord. Let's go to proof. So as we have been doing, we have been using the congruency, right? We have been using congruency of the triangles so far. Let's try to use that once more. Let's start with whatever we know. So let's write, what two triangles are we considering? We are saying COE and we will see DOE. We'll consider these two triangles. Okay. What do we know about these two triangles? OC is equal to OD, right? Let's write it here. OC is equal to OD. These are the radii of the, why do I spell it wrong every time? These are the radii of the circle. So that is why OC is equal to OD. What else do we know? We know, we have been given this, that OE is perpendicular to CD. This we have been given, which means OE is at a right angle to the chord CD. What else we can see here? We see that this OE is equal to OE. Why OE is equal to OE? OE is the common side for the two triangles. So this is going to be anyway equal. Common side of the two triangles. This is something which has been given already. So now what do we see here? We see if OE is perpendicular to CD, what does that mean? This means OEC is 90 degrees. This means this is a right angle triangle. OEC is a right angle triangle, or COE is a right angle triangle. Similarly, DOE is a right angle triangle with the right angle at E. Okay. So these two triangles are right angle triangles. Triangles are right angled triangle, and what do we see? OC and OD are hypotenuse of the triangle and OE is the side of the triangle. and we already have seen because OE is perpendicular to CD. So we know that OED is equal to OEC. Okay, these two angles are equal, and they are equal to 90 degree. Right? So we have what we have here is right angle, hypotenuse, side. We see this congruency here. Okay, this is the congruency between the two triangles. What two triangles? These two triangles. Should not move it. Instead, I should write it down. COE and DOE. This is the triangle. This is the triangle. And this is the congruency. So what that means now is corresponding sides will be equal, which means what corresponding sides do we need to prove equal here? I already told here, right? CE is equal to DE is something which we had to prove. So for these two triangles, if you see, CE and DE are corresponding sides. So CE will be equal to DE, and hence proved that E is the midpoint of the chord CD. Done? So now if we try to write the theorem, how will we write this? This will be theorem number, what was the last one? 4. So this will be theorem 5. Theorem 5 will state that if a perpendicular line drawn from the center of the circle to a chord bisects the chord, right? Perpendicular line drawn from the center of the circle to a chord bisects the chord. That will make the theorem 5. So before we close, let's do one more theorem. Okay, that will be the last, I promise. So for that, we'll draw a circle. Okay, and this time we have to take two chords. Okay, let's take two chords. So here, let me make the center of the circle, and then what we'll do is we'll name it A, B, C, D. Circle center, I'll call it O. So let me this is cutting too close. Okay, it's fine. It's visible, right? So it's fine. So here what I have been given is, let's see what all is given. we have been given AB and CD are two chords of a circle with center O. Okay. What else are we given? Other thing which is given to us is AB is equal to CD. So what we are saying is the length of the two chords is equal. Okay. So what we need to prove now is the two chords will be at the same distance from the center. What does that mean is, okay, this is, let me call this point. Okay, wait, first I'll draw. And what I'll call is, this point I'll call E. And I'll call this point as F. There is something wrong here. Why is my F not moving? This is O, and I'll write here F, and I'll just move it here. This is a better way. Okay, so now AB and CD are two chords of the circle with center O. I have been given already that AB is equal to CD, which means the length of the two chords are equal. And now what I need to prove is OE is equal to OF. What does that mean? I need to prove that these two chords are at equal distance from the center. These two chords are equidistant from the center. Okay, so we'll start with the proof. Okay, so what we'll do here, again, as we have been doing so far, let's draw triangles. Let's draw triangles. So here what we know is AB is equal to CD, which is given. Then what else do we see? We see OA is equal to OC because they are the radii of the same circle. Then OB is equal to OD. Again, radii of the same circle. So this means in and COD. What are AOB and COD? These are two triangles that we are considering. So in these two triangles, AOB and COD, what is happening there? In these two triangles, corresponding sides are equal. All three corresponding sides are equal. So by SSS congruency. These two triangles are congruent. These two triangles are congruent. Let's make it, yeah, these two are congruent. So if two triangles are congruent, then what will that mean? What will that mean? That just means that, their corresponding sides are equal, their corresponding angles are equal. But here we have to prove that OE is equal to OF. So if the two triangles are congruent, it will also mean that their altitudes will be equal. So here OE, when we are saying OE is the distance from the center of the circle to that chord, this means it is we have drawn a perpendicular, it is a altitude of that circle, on that chord. And similarly, OF is the altitude on the side CD of the triangle OCD. OE is the altitude on the side AB of the triangle AOB. OF is the altitude on COD. Because these triangles are congruent, their sides are all equal. So the distance from the vertex to the other side, opposite side, which is the altitude, will be equal for the two triangles. Altitude of the two congruent triangles. Right? That is how we have proved it. So now this is the proof. There is another way of proving. This is proof 1. We'll say hence proved. Let me try the second proof. For second proof, what we will do is we will just consider these two small triangles. What triangles I'll consider? I'll take AOE and I'll take COF. Okay. Let me draw here the two that we are talking about, these two triangles. Now, what we know about these two triangles? We know that OA is equal to OC, which is the radii of the two circle, two radius of the same circle. So that is why they are equal. What else do we know? OE is equal to OE. OF, no, we don't know this. What we know is AB is equal to CD, right? We have been given this. So from this, we can make out that the E and F are midpoint of AB and CD. So this means that half of AB will be equal to half of CD because they are equal, right? Which will mean half of AB is, we can say, what is half of AB? AE is equal to CF. AE is half of AB and CF is half of CD, right? So because these two chords are equal, and E and F are AB and CD are equal, so then their then their mid, yeah. Okay, here I missed to tell one property here, right? Um, this is the OE is the distance from center of the circle to the chord. So when we are drawing from center of the circle to the chord, we are drawing a perpendicular line, right? When we have to find the distance, we draw a perpendicular line. So this OE is the perpendicular line to CAB. In one of the earlier theorems, we had seen that if we draw a perpendicular line from the center of the circle to a chord, then it bisects the chord, right? So this means that this E will be the midpoint. Similarly, this OF is the line which is it is the height of it is the height of or the distance from the center to this chord CD. So this distance is formed when we are drawing a perpendicular, and we had learned the line which is a perpendicular line which is drawn from center of the circle to the chord bisects the chord. So this means these two sides are equal, right? So that is the reason AE is equal to BE, CF is equal to DF, right? And because AB is equal to CD, so when half of AB will be equal to half of CD, AE is half of AB and CF is half of CD. So that is how we are saying AE is equal to CF. Okay. And what is the third thing that we know? The third thing that we know is that angle OEA and angle OFC are 90 degrees. So OEA is equal to OFC is equal to 90 degrees. So if we consider these two triangles, what do we see? OA and OC, these are the radius of the circle. They are equal. Apart from that, what else do we see? They are also forming the hypotenuse of the circle. AE is equal to CF. What is it forming? This is forming the side of the, basically I should say, corresponding sides of the two triangles. And this is the, what is this? This is the right angle. So these two triangles are right angle triangle and they are satisfying the RHS congruency property. So these two with RHS congruency property, these two triangles are congruent. AOE and COF are congruent to each other. This triangle, they are congruent. Okay, these two are congruent. So what does that mean? This will mean that corresponding sides will be equal. The other corresponding sides will be equal. So we can say that OE is equal to OF. And this is what we had to prove, right? Hence proved. Okay. So with this, let's write the theorem. Which theorem will it be? I guess 6. Yeah. So how do we write this theorem, we have two chords of the same length, and we have to prove that the distance of the two chords from the center is equal, right? So two chords of a circle having the same length will be at an equal distance from the center of the circle. Two chords of a circle having the same length will be at an equal distance from the center of the circle. In fact, it is not just two chords. Basically, all the chords which are of the same length in a circle, they will be at an equal distance from the center. So all chords of a circle which have the same length, they will all be at the same distance from the center of the circle. So that is your theorem 6. And as we have been doing, we'll also see whether the converse of this theorem is true or not. So how will we do the converse of the theorem? For that, let me first copy this circle, this diagram, and let me, oh no, what just happened? What just happened? Did it not copy properly? See, Control V, yes, this time it copied. So what do we need to do here? Here we will be given, what is given? Here earlier we were given that these two chords are equal and we had to prove that they are at a equal distance from the center. So here it will be opposite. Here we will be given that AB and CD are at equal distance from the center, which means center is O. Okay, which means that OE is equal to OF. This is given to us. Okay, let me just remove it because this is let's make a fresh one. Okay, let's make a fresh one. This is a circle. This is the center of the circle. This is the chord AB. This will be the chord CD. This will be the distance. Okay, and similarly, I'll make this. Okay, so let's call it A. Let's call it B. Let's call it C. Let's call it D. AB and CD are two chords. Center of the circle is O. And this point is E and F. E and F. So we have been given AB and CD are at equal distance, which will mean OE and is equal to OF. And because we are talking about the distance here, distance means to be perpendicular. Right? And then what we will need to prove here is to prove ABCD, they are equal. We have to prove AB is equal to CD. And then let's start with the proof. So as usual, let's try to draw the triangles so that if we can prove, they are congruent, then we will be very easily able to prove that these AB is equal to CD. Okay, so how do we prove? Now we have been given that, let's start with whatever is given to us. OE is equal to OF. We know that OA is equal to OC. We know OB is equal to OD. And we also know that OE and OE is perpendicular to OE is perpendicular to AB. And we also know OF is perpendicular to CD. Okay, so these all are the things that we know already about this. So let's see what we can prove using this. What we can prove using this, again, one which I see is right angle hypotenuse side. For that, if we consider, let's consider these two triangles, AEF, no, AOE, and other is COF. These two triangles, here OA is equal to OC. This is the right angle, and it's also the hypotenuse, and we have this OF is perpendicular to OE, and OE and OF are equal. So this makes it a right angle hypotenuse side congruency. So this will mean that AE is equal to CF, right? So let's write it down. We are going in the correct direction. Okay, so let's write it down. These are the two triangles that I'm considering. And here I will write OA is equal to OC, which is the radii, and also hypotenuse. Then we know that OE is equal to OF. This is given. And we also know that these are the side. And we know OE A angle is equal to OF C angle equal to 90 degree, which is angle, and this is the right angle. So with RHS congruency, right angle hypotenuse side, this congruency, we can say that our triangle AOE is congruent to triangle COF. Congruent, right? And then from that, we can say corresponding sides are equal. So which means, what this means, AE will be equal to CF, right? Now we know that we have seen in an earlier theorem, right, that a line which is a perpendicular line drawn from the center of the circle to a chord bisects the chord, right? So OE is a perpendicular line drawn from the center of the circle to the chord. So this means this line is bisecting the chord. So this means that AE is equal to BE is equal to half of AB. And similarly, OF is a line, perpendicular line drawn from the center of the circle to the chord CD. So it is bisecting the chord CD. So this will mean that CF is equal to DF is equal to half of CD, right? So when we are saying AE is equal to CF, we can also say that twice of AE will be equal to twice of CF, which is twice of AB is AB. Oh, sorry, twice of AE is AB, twice of CF is CD. So we have proved that. We can write here proudly, hence proved AB is equal to CE. This is what we had to prove, that these two chords are equal. So if we write it in the term of theorem, which will be the theorem 7, it will be if two chords, or we need not write even if, two chords that are at an equal distance from the center of the circle are equal in length. Two chords that are at an equal distance from the center of the circle are equal in length. Okay, so with this, we have totally covered from theorem 2 to theorem 7, which is quite a lot. And I think I have the concepts that I have covered in this chapter, in this video, you will be able to work on exercise 5.3, 5.2, 5.3, and I think 5.4 also. So we have covered all the concepts that will help you complete exercise 5.2 till 5.4. Please make sure you try out the problems in all these exercises. And if you run into any difficulty, if you have any questions, drop a comment and I'll make sure I'll reply to your comment. Bye bye.